Yeah.
Okay. So we are working on the Garnet project of the EJU Earth data. So these are our team members. This is Urmi Ghosh from IIT Kharagpur. She is pursuing her PhD. This is Dr. Zhang Zhao from professor from Zhejiang University. This is Natasha from Moscow University. She is pursuing her MS, and this is me. I had completed PhD from IIT Kharagpur. Right now, I am not affiliated with any institute. It's like a doctor without border. So let's see what we are doing. Sorry, what's happening? Okay, so these are the project objectives as I have shared earlier. Among these project approaches, and these data accumulation part, data classification and sorting part, and study of data, assigning them to each objective. We are doing all three of them simultaneously between our different group members and undergrads who are also working with us. So for in case of data accumulation, we are working with two different databases, GeoRock and ArthChem. So it's a very important part to merge these two data sets. So our team members are working on the data merging, starting with similar tectonic setup. How? Just let me go. So this is from our GeoRock database. As you can see that this is according to the tectonic setup. These rocks are from different tectonic setups, and the bulk of the data is actually from the interrupted volcanics. So this is something we have divided interrupted volcanics into different subdivisions, and on each subdivision we are working. The important thing is to merge these GeoRock interrupted volcanics or other tectonic settings which with other data set from this ArthChem database. So in ArthChem, as of now, if you download the whole thing, then we get the division according to the rock name. But we can also download separately according to tectonic setup. So it has been done, and the data is being amalgamated and produced in a similar setting as GeoRock as we speak. Now let's go back. So the next big objective is obviously data filtering. So it's important to understand the NaN values. So how we can use it or how we can remove it, that will based on different literature understanding and the understanding of the data. The second thing is to exclude the data. Second thing, which I have talked with a few earlier member of a pyroxene group who have already done it, who have already experienced in data filtering, like Ben. So from them I have got some idea. So it's like then I excluded the data for where the summation of major oxides of garnets are not between 99 to 101%, because garnet is generally an anhydrous mineral. So obviously the total should be around 100. Second interesting thing about garnet is the Si content in tetrahedral site. So all values that is between 2.96 to 3.02 are included automatically, because that should be how much silica is there. Now, if there are some values which are in the outer range, then that should be investigated. If in case there is really something that's prompting a decrease or increase in silica values, then that will be investigated and included. Otherwise they will be excluded. So I have done this histogram and probability density plot of different garnet cations, and the value leading to the deviation from an ideal Gaussian pattern will be investigated. It's not like they will be excluded automatically, but we'll take a closer look at that. And this is how we are doing the data setup, like from GeoRock database to interrupted volcanic setup to garnets from geoliths, and now the principal objective is to focus on all type of mantle garnets. This is some of the major element plots we have done, and these are some of the 3D plots. This is how the xenolithic garnet setups. This is how the scatter is between almandine gross solar pyrope. This is how the setup is. This is some trace element plot where we can see some clear patterns, and this is how the H2 is varying. and the H2O concentration, there is not a lot of data available, especially in the case of xenoliths. So this is one paper by Lee Hai Young. It's in 2018 chemical geology paper. So from there, the xenoliths and cyanopyroxenite type xenoliths were investigated. And this is some of the representative plot from ArcChem. So going forward, we will do an in-depth investigation of the xenolithic garnets. Then we'll do careful understanding of all types of mantle garnets. We'll look into variable water content of mantle garnets and a ferric upon total iron content of the mantle garnets to understand the mantle redox condition. Correct estimation of ferric is really important. So we'll take some help from the machine learning group if needed, because we'll need to compare the ferric estimation we are getting from EPMA with the ferric estimation of Mosavier techniques. One of the undergrads is actually compiling the data from Mosavier spectrometry, so that we can get a comprehensive understanding. And also about the data amalgamation process, which is really important. So for that, we'll need to do like DOIs from one data set, then will be compared to the DOIs of the secondary data set, and then we'll see if there are some overlaps, and we will filter the data according to this. And then the whole approach will shift slowly towards machine learning approach. Thank you. If you have any questions.
Okay, yeah. You could end the screen share. We would like the second group, Con, for Igneous group. So could you share your screen? Yeah, if the audience have any question for the gardening group, you feel free to open your mic and ask a question now, as the second group is preparing. Okay. So, Jikang, please go ahead.
Okay, can you hear me?
Yes, we could hear you and see it very clearly. So go ahead.
Yeah, and this is the Igneous project, and here is the group members. Akasahu, Pasaka, and Mando is from India, and Weisui, Jinfeng, Zhikang, and Ming is from China, and Benta is from Philippines. And the scientific question is what did the thickness and the thermal state of the crust and lithosphere mantle change during condition and basin forming process? And the next one is how did the flows derived from the Indian plates contribute to the crustal channel flow and high velocity but high conductivity layer? The first step we pay attention to the first one, and the evolution of thickness of the crust and lithosphere mantle of the circumtibet area. One is the crust thickness. We use the isotope some elements ratio to respect the crustal thickness, but there are some problems. One, it will the ratios will be affected by the source and by the magma evolutions. So we want to that's give us a thinking to want to search for a better index. And the next one is the lithosphere mantle thickness. We also use some element ratios to represent the lithosphere mantle thickness. And one question is we don't know the amount of the peroxenite is from the mantle of or from the derive or from the derived from other source. So that gives another question: how to identify and quantify the amount of the peroxenite? And we now focus on the first question. And here is the work we have done. We collected the GeoRock database and database of the Chapman. And in this week, we divided our teams into two subteams. One is working on the Chapman's. The subteam one is working on the Chapman's database. And in his database, we need to add the rock type, mineral, location, and elevation. And we also add the two new data into this database. And the subteam 2 work on the GeoRock database. And Akasa, who is the leader of the subteam 2. And their work is according to work times to do the data cleaning job. And the next week plan is continue dealing with the already database and preparing the machine learning progress with the Chapman's database. But here's question for the according to my know, all the explanation of the algorithm is in Chinese, so we need some tech group students to help us to explain the algorithm in English. Then we want to involve in the EarthCham database, and then we set up the standard for the data cleaning. And then for other groups, at last we need to do the paper management. And here is the work channel. And the first one is set up the database. Then we do data cleaning. Then we do machine learning. Now we work on the first two steps. Thank you.
Okay, but from my own interpretation, that people could use Google Translate to help before the formal translation occurs, because according to Wumi, that the Google Translator that works when she read other people's codes. So Wumi, would you open your mic and share some of your experiences?
Yeah, hello, I'm audible?
Yes, we could hear you.
Yeah, so for the codes, what I did, only the comment sections are in Chinese. So the main code is already written in English. So the comment section we can actually copy and paste, and in Google Translate it works. So we can translate it into English.
Okay, thanks, Wumi, for sharing. Yeah, it's one thing that we are going to improve in the future, is that for other codes that we should comment in bilingual if it is most ideal situation. But if not, then we will have to rely on other translation tools to move on, because there are too many codes nowadays that are being produced, and it will be too much task for the machine learning team and going back and to change every line of codes, like say, to make them bilingual. So it's a step-by-step process. But I would recommend that in the future, that for all the tech teams that trying to be bilingual, yeah, just try. You don't have to fully implement that, but to at least give some keywords or ideas so that people could get along with it. And together with the help of the Google Translate or other translation software, I think it will be more efficient for people to understand what's going on. But another thing that I should point out is that we need to record some videos now and then to explaining some codes, because some codes, even is a language that people could understand, it is still not so intuitive for people to know what does it really mean for those codes. So let's record some videos. So even for some users, you could record some videos if you are familiar with a certain type of codes, and you could record it and upload it in the YouTube account. Okay, so now let's move to the third group, the hydrogen group. As it is absent today, Juan told me earlier on. So now let's have the organic chemistry group. So Minghao, could you have the screen share?
Could you hear me and see the screen?
Yes, I could see. Yeah, go ahead.
Yes, thank you. Hello, everyone. We are organic chemistry group, and this is our members. I'm Zhu Minghao. First, let me talk about our scientific problem in the geology view. As you know, the environmental issues are getting more and more attention. So there are more and more studies on global change and carbon cycle. The organic carbon cycle in estuary coasts is an important part of global carbon cycle, and it is also the difficulty and the focus of today's carbon cycle research, because you can see its material exchange is very complicated. Our research focus on the carbon cycle on the estuary coast. Now let's see our scientific problem in our data science view. In general machine learning problems, we often give an input and get an output, but the intermediate process is quite complex, and we don't need to know the specific process, just like a black box. However, in our research, we pay more attention to the intermediate process, even than the output. In other words, we want to know more about how to get an output from an input. Here is our data. In general machine learning problems, the number of the samples is usually greater than the number of variables, but our data is just opposite. As you can see, the variables, we often have more variables and few samples. The variables are chemical element or isotope or biomarker. And there can be hundreds or even tens of thousands of variables, and each variable is very important because it contains rich geological information. However, it is difficult to collect samples. Usually, we often have hundreds of them. Now we have collected 11 papers in total. The collection of data requires strong domain knowledge. In addition to the content of variables, we also need to collect the environmental and geographic information. So it's a little difficult. In the future, we will continue to collect data, and at the same time, we will use the data we have collected to try some machine learning algorithms. That's my talk. Thank you for listening. Any questions?
Okay, any questions from the audience? Yeah, actually, I have questions. So when do you? So have you begun any real machine learning process now? Have you been building the model?
No, because I haven't to know what the specific question we want to solve.
Okay, yeah, my interpretation is that you need to sort that out. I think there are a lot of questions available from Dr. Tao, according to my previous conversations with him. So yeah, please sort out the science questions. And now I think you could build machine learning models now, although you only have 11 publications recorded in the database, but I think it's already a very small database that you could explore more and in building model, and because the amount of data could be accumulated in the future, so you don't have to spend all the time in collecting data. And from my perspective, I think it's crucial for your team to begin the building of the machine learning models. But before that, you should be targeting one specific question. As there are multiple science questions that are relevant to this database. So please fix one. Yeah, in your future group meetings, please talk about it. Okay, I will also confirm with Dr. Tao for that. Okay, it's great. Okay, now let's move to the next group. So for the internet one, or the journal group that are collecting different journals. So Chen Ziliang, would you share the screen? So is Chen Ziliang around? If not, then we can move to the next person. I think he was here. I let him in.
Hello.
Okay, Chen Ziliang. Yeah. Please share your screen.
Oh, I'm sorry. Okay.
Okay, we're good to see you. So go to the cover page.
Good evening, everyone. And I'm the leader of the journal group. My name is Chen Ziliang. And these people on the screens are the members of our group. And the journal group's purpose is to establish a whole network periodical database and provide geography periodical information such as DOI, title, abstract, download link, and etc., and relevant retrieval code, so as to facilitate groups of students to retrieve relevant data to get information more quickly. And the progress of our group this week is as it shows, and so far we have collected about 809,721 articles from CNZ, Elsevier, Springer, Online Library, Valid, and other journals. and the main task of this week is to call the journals needed by the members in the science group. At present, the task has been basically completed, leaving only the last one, and the division of labor within the group is as follows. And we also try to use dynamic chord methods to reduce the time of analyzing journal volume pages and speed up the process. However, this method is not yet perfect, and it is easy to be detected in the process of calling. And our next task is to call journals of geoscience world. And since it has a high anti-caller mechanism, we may need to call in a different way. And that's all. And thank you for listening. And I'm sorry I'm late.
It's okay. Thanks to Ziliang for sharing. So do we have any questions from the audience? Yeah, now you could exit the screen share and it'll be like the next group, the machine learning group, to share the screen. So during the meantime, so do we have any questions from the audience? So Arka asked a question. So what is meant by dynamic crowd methods? So could you explain, Ziliang? Yeah. Dynamic crowd methods.
Is to call the data, like we search the internet, like human. Maybe I'm not explained well.
Okay, maybe you could type more in the chatting block. for explanation. Okay, so next group is the machine learning group. So He Cang, could you share your screen?
Yep, sure. Okay. Is it clear to hear me? Okay.
Yeah, we could hear you.
Fine. Actually, most of their content have been told last time, but also there's some news here. And I'm Sandy, and the leader of the machine learning group. And most of the people shown here are the members of this group, and part of them worked here before, but they left, and the rest of them are working right now. So actually, what are we doing right now is to provide the science groups with some technical assist, like to help them solve some machine learning related problems and help them work with the codes of their machine learning related algorithms also. And the second things we are focusing on is to explore some new algorithms, and those are algorithms related whom have not been coded already. And also we put all of the words on the Git platform, and we will synchronize them into the GitHub platform also. And we have both of them, both of their platform with the algorithms we made and we code before. And we are trying our best to make them in English version also. And part of them has been translated already, but we are working on them, and we will do it step by step also. So what we are working now is to modify some algorithms rootedly, because most of the algorithms are packaged already by the other coders, and most of them are in the scikit-learn package or some platform like the Google's TensorFlow and like the Facebook PyTorch and something like that. And we should modify them to let them adapt it to our project needs. And the second thing is to actually we have two people working on two different kinds of clustering algorithm. The first one is K-means, and he is trying to add some methods like the automatically adaptive inertial weighting to K-means. And the second one is about the DBSCAN, and Sunxin is working on it. And he will try to just modify them using C language, because as we all know that most of their code are written in C language to make some package for the Python, and he's trying to do it by code them in C language. And the second thing is to explore some actually brand new algorithm like the semi-supervised, and it's my work, but I'm busy with my school work also. So when I have time, and I will do more work, I will spend more time on them. And the third one is also matters to all the other scientific or science groups, and some groups has pointed out before, it's quite necessary for us to synchronize them and put them in English, and we will just try our best to do it as soon as possible. And actually, there is a bunch of codes as the Professor Zhang mentioned, so we will just work on new algorithms and try to solve some problems, and at the same time we will just put them in English too. So here is the plan of our machine learning group. We will just put some algorithm package already into practice, and which means that some algorithm didn't discover before, or didn't weren't used before, and we will just to explore them. And the second thing is like their work on their clustering algorithms will modify the source code of the algorithm, like the Gaussian mixture and like the k-means and also DBSCAN. And the last one is about the assignment of the machine learning groups, because most of the group members are working on some specific science groups. And if your science group have a need on their help, or especially on some, or especially on their technical assistance, and you can just make a content with me, because I will just try my best to make some, to have you some proper candidates and to let them to work in your science group to solve their deployment of the course. And that's all. Thank you.
Okay, thank you. And we'll also make some videos for explaining some of the codes. Okay. Okay, so you can exit the screen share, and we'll ask the cloud computation to share the screen.
Yeah, sure. Okay. Could you see my screen clearly and my voice, my sound?
Yes.
Okay. Now, hello everyone. I'm Jiahua, and I'm the leader of Cloud Computation Group. Now I'm studying in geophysics in University of Padua. And the other people, Chuan Yu, Jiashen, Xingchen, San, and Jingceng, they are my partners. So our missions and goals is providing powerful computing resources and service, and porting code to Deep Engine. We also call Huawei Cloud to realize pipeline operation, then monitoring and optimizing the code execution. And finally, combining Git and GitHub, Git or GitHub for code management. So let me show the work that we completed in last week. So firstly, about the code managing, we created a GitHub account or repo in order to facilitate the code management and sharing, because the official language of Git is Chinese, and that of GitHub is English. So so it's maybe it's the best way to show the code about the machine learning method to the international students. And about the video production, Jingceng complete the video about basic tutorial of Docker, and which is powerful tool for the code, maybe the code or environment migration. Yeah. So and he uploaded it to the Bilibili space. Then about the intergroup assistance, Chuan Yu, he helped the Kubernetes group to maybe focus on the Kubernetes data or the papers. So, for example, assist the Kubernetes in negative sample statistics, and download papers and read them, and looked for broke names relative to Kubernetes method. So in progress, we will make the video about the connection and the usage of the Windows subsystem Linux subsystem about the Linux and the VS Code and PyCharm, because short parts or several people want to use this way to maybe to build the environments for the Python, the Python or Docker, and then to complete the hotspot analyze function to find or to do the optimize for the machine learning codes. And finally, we encourage the people to assess maybe the Kubernetes group to help them to do with, for example, the data processing or the codes, maybe the codes running. So yeah, so that's all. Thank you. If you have any questions, please.
Yes.
Yeah.
Okay, I have several comments. So first, I think that for the codes that if we make them bilingual, then we'll try to make them bilingual. So writing two languages together as comments will be easier for future users to use. And second, for the explanation that in making the videos upload to Bilibili, and not only that, we also need to record the video speaking English so that we can upload the video by YouTube, so that it will be easier for our users to use in the future. So I think this work,
okay.
Yeah, this work will take some amount of time, but let's do it one by one. I think that the machine learning group and the cloud computation group that could work together for this. Since Hechan is in charge of the GitHub and Jiahua is in charge of the Git, so some of the videos corresponding to it, I think could do in bilingual too. And the codes could be shared because the codes could be in in two languages, just written hand by hand, shoulder by shoulder with each other. And another thing that they point out is that from the Internet Worm group that they mentioned that they do have codes that they would like to run for 24 hours or 48 hours on Huawei Cloud. So is it possible to manage to do that? Because for some of the Internet Worm codes that it takes extremely long to do that. So it's not practical to use their own personal computer to run for days and nights for a couple of days to do it. But I think Huawei Cloud is perfect to fit in that position.
Okay, we will deal with that. We'll deal with it. Yeah.
I think according to Jin Yicheng, the codes are already available. So I think yeah. So we should be able to put it on the Huawei Cloud. Okay. So any questions from the audience? But I think you could exit the screen now and let the next group leader to share the screen. But during the meantime, do we have any questions from the audience? Yeah, by the way, I noted that a lot of people, I know that you are all in a hurry because actually tomorrow will be the National Day in China and it will be a break. So in the cover page, I see a lot of people's names are spelled wrong or institutions' names spelled wrong. I suggest people don't use acronyms unless your university extremely famous like Stanford or UC Berkeley. I think that's okay if you make acronyms. But other than that, I suggest everybody use the full name of your institution and also check with the group member that you spell their name in the right way. And I see a lot of names that are wrong. Okay, so Hudan, please share your screen. Thank you for waking up early since Hudan is she's in the Bay Area, San Francisco, and it is 7:10 a.m. in the morning. So Hudan, could you share your screen?
Sure.
Okay, I'm glad that you are awake. Maybe you're still sleepy. Okay, go ahead.
Can you see my screen?
Yes, go ahead.
Okay, so here are my team members. And this week, we already had a joint meeting with Diamond's team 2 days ago or 1 day ago, I don't remember. And the major topic they're interested in is how to measure similarities between different cratons. And the one approach I came up with is use the kernel functions to quantify pairwise similarities between cratons. So let me first introduce kernel here. So the kernel is a transformation of the distance, simply speaking. So for example, maybe you have already heard of it, the radial basis function kernel, which is short for RBF also, is a transformation of the L2 distance. And has an additional parameter gamma. So here is the formula of the RBF kernel. And since it takes the negative exponential of the distance, so larger distance will have smaller similarities and vice versa. So with kernel functions, we can get a n by n similarity matrix, and n is the number of cratons. So here is an example. I chose only 3 cratons from the original data set. And here is the column stands for the various kinds of minerals that exist in the data set. So, and each cell in this table represents the percentage of that certain mineral that accounts for within that kraton. After the kernel transformation, we can get a 3 by 3 matrix. You can see here. So each cell in this similarity matrix can tell us the pairwise similarities between cratons. So, for example, in this matrix, you can clearly identify that which pair of craton are the most similar with each other. So here, Slave and Siberia has the highest score. So they are most similar with each other. So this is the major topic we discussed with diamonds. And and here's the next steps. So we still have some problems with the feature importance interpretation, including XGBoost or Light GBM algorithm. Since both of them can handle missing values very well, both of them give us pretty good prediction score without imputation beforehand. But we still have lots of problems in the interpretation of the feature importance. So, for example, suppose we have a feature that is the top one important in our prediction, but it has lots of missing values in its original data. How do we interpret the contribution of those missing values? So we are still searching for more articles or papers or informations about how to solve this question or how to answer this question. And also we are happy to learn ideas from other groups, including machine learning group. If you have any insights or you have any ideas about this problem, please feel free to reach out to us. And another problem is the model optimization. We are still doing some research on the Bayes optimization. Since I was kind of busy last week, so I haven't started on this part. But as soon as I made any progress, I will have joint meeting with Cloud Computing Group this week or next week. So that's the updates with Diamond's team. And as for the Carbonite's team, our current progress, still we are working on different approaches to impute missing values. I've already tried KNN imputation and linear regression imputation, and another task for us is to check the distribution, if the distributions before and after the imputation are the same. So Zhikuan is actually working on the hypothesis testing. And he is also doing research and trying to wrap up everything he knows into a single document. And actually, the probability plot is another approach I came up with during I was doing the research on this topic, because since the data set for Carbonite's team is really large, so there definitely exists a big concern in this hypothesis test process, which is the test power. Since their data set is really large, so during the hypothesis test, maybe a teeny tiny difference in the distribution can result in an extremely small p-value. So if we don't want to be too harsh or too picky in the imputation or in determining the difference between the two distribution, then maybe we can use a probability plot to check if the distributions are the same. But these are all thoughts, or both of them are available approaches. We can try both of them. So it's still on the progress. And another task is the random sampling. Also, some of our team members, I believe it's Zeyu and Hu Yue, they are both doing research on different approaches of random sampling. So that's it for the updates and progress of our team. So feel free to ask me any questions.
Okay, thank you very much. So do you have any questions from the audience? And I think that for different groups, so that you probably could contribute your perspective when you are seeing the presentation from different groups. So feel free to contact the group leaders or the other group members to share with them about your ideas. So you could contact them directly in the Slack chatting group. Okay, great.
Okay.
Okay, so have a good day or have a good evening, everybody. Thanks for participating.
Thank you, everyone.